Okay, when we are dealing with predictive modeling, uh, we have to consider what happens when we keep trying to add more and more predictors. If you have a bunch of predictors like 20, 30, 100, or even 1000 predictors sometimes, depending upon how big the data set is. Now, adding more predictors, what are the issues involved in that? The more predictors will result in less sum of squared error, as we talked about previously. And of course, that means it may seem like a better fit. Okay. But not including a predictor that is actually correlated with the target variable may increase the average error of the predictors, which is called bias. So standard error, when we do tests, the standard error of coefficient, that may be higher because you're adding spurious predictor variables. Okay. So we need to understand which variables, predictor variables should be included. Of course, there are other issues as well, as we will discuss in just a minute. Okay. So problems with more predictors. If you have more predictors, what's going to happen? Well, if you want to maintain a larger database, then you're going to have to collect more data and maintain the data, clean it, and all of that is going to cost you more. So cost of collecting and maintaining data. And some data, it may not be possible for us to collect. So feasibility of data collection is an issue as well. And when we collect more data and there's going to be errors in the data for not, you're not going to get perfect data always. So there will be some accuracy problems. So if you have less number of predictors, you have less headache that way. So just because you have some predictors doesn't mean that you have to use them. You use them only if it will increase your predictive ability, predictive accuracy. So the more predictors there are, okay, there are more chances that you may have missing values. Okay, some values that are not available in the data set. So if you have missing values, then you have to either delete that row, because regression analysis will not be able to handle if there is a hole in the data. In a column there is one observation missing, then either you have to replace that missing value with something reasonable, in which case you can keep the data, or you have to get rid of that row. Then only regression will work. So if you opt to get rid of the data, then your available sample size will become smaller and smaller. That's not a good idea. And if you impute, if you figure out what could be the value and impute it, then you're introducing your guesses there. So both options are not perfect, but of course throwing away observations is more of an issue than imputing. Imputing definitely is a better option than just throwing away observations. Now, this is an important issue. If you have more predictors, there is more likelihood of multicollinearity. Multicollinearity refers to the condition where the predictor variables are correlated between themselves. Okay, you want the predictor variables to be correlated with the target, because these variables are supposed to predict the target, and if they have high correlation with the target and they have more information about the target, and we will be able to successfully use those in predicting the target. But if the predictor variables are correlated among themselves, so that means whatever correlation they have with the y, they are sharing that information, that they are sharing that correlation with some fellow predictors. So that issue is called multicollinearity. So if you have multicollinearity and if you don't take care of it, you'll end up with very unreliable equations for predicting target y for the future. The regression coefficients will be very unstable, and you'll have less confidence in your prediction. And so you can run a correlation analysis between the predictor variables and then set a threshold value. So anything over 8 plus or minus, below minus 0.8 or above 0.8 or 0.75, because negative correlation is also a problem. So closer to zero, correlation closer to zero is what we want. Okay, you don't want high positive or high negative correlation. So we can use, there are procedures available in packages where we can set threshold values and get rid of variables that are highly correlated. And we also need to have a sufficient number of observations. Usually in the context of data mining, availability of data is not an issue. But generally speaking, we need to have at least, if you have two variables, p equal to 2, so 2 plus 2 is 4, 4 times 5, you need at least 20 observations to come up with a reasonable prediction. Okay. Which is easily met in the context of big data, right? So if you have like 1,000 variables, then you have 1,000 plus 2 times 5 and so on. So it's kind of a thumb rule. This is not to be taken as a law or anything like that. Now, we already talked about this first situation. Predictors that are uncorrelated with the dependent variable increases the variance. So if you have a predictor that has no predictive value, predictive ability with respect to the target, then we need to drop it off. And then, of course, there are procedures, stepwise regression procedures, model building procedures that will automatically do those kinds of tasks. Now, parsimony is an important property of good models, which means given same predictive ability, you want a model that is less complex, it has less number of variables, because if you have less variables, there is less likelihood of multicollinearity, more stable coefficients, and high predictive accuracy, and then you will have less likelihood of missing values and so on and so forth. So you need to make a judgment when you have two different models. They both have about the same predictive ability. Okay, one has slightly less predictive ability but much simpler. So a much simpler model with almost the same predictive ability is preferable than one that has marginally little bit better predictive ability but a very complex model. So it's kind of a trade-off there, and you have to use your judgment to figure out which one is best and where the trade-off is in which way the trade-off is favorable.